Hey everybody, it's Dr. J, and today we are talking about oxidation, reduction, reactions. Let's talk about chemistry. Oxidation reduction reactions, or what I'll be referring to them as redox reactions, are basically your reactions in which our electrons are going to be transferring right from one reactant to another. Okay, so this is basically where our oxidation states will start to change with some instances. So when we really think about it, a couple of different reactions we've probably seen before, like iron reacting with oxygen to form iron oxide or rust. This is an example of oxidation reduction occurring, right? This redox reaction. Now it's occurring, right, because a transfer of electrons are actually taking place here, right, from our iron and oxygen over here to form our new compound. Another example, right, even this combustion reaction, right, when we react hydrogen and oxygen together, right, transfer of electrons are taking place even here. Okay, so a lot of reactions that you kind of been exposed to already are redox reactions. It's just a transfer of electrons. So anytime electrons are transferring, we have a redox reaction. Couple things are always going to happen when you have redox reactions. You're going to have your oxidation, right? Because this is a oxidation and reduction reaction. So you're going to have your oxidation and your reduction taking place at the same exact time. At the same time. What Future say? He said at the same time. You know what I'm talking about? Shout out to Future. All right, but oxidation and reduction is happening at the same time. All right, if it's not, you don't got redox reactions occurring. So let's talk about exactly what oxidation and reduction is. Oxidation is the loss of electrons. The loss of electrons. Reduction is the gain of electrons. So let's look at an example here. Let's say we got sodium and chlorine reacting to give us our sodium chloride, right? If y'all didn't know, this is a redox reaction. Like I said, a lot of reactions are redox reactions in most cases. So oxidation is the loss of electrons. Let's look on the sodium side here. All right, so what happens, right, when our sodium forms this sodium chloride salt, right? That sodium starts off neutral, and then it transforms to that sodium cation. So when it transforms to this sodium cation, right, in this case, it's losing electrons. How do we know it lost electrons? Well, the sodium became more positive, and we understand that electrons are negative, right? So when we lose that electron, this is what it's looking like, right? That electron has been lost. Now it's separated. So when sodium loses that electron, what's going to happen to the electron? Well, in this case, some gaining and losing is occurring here. So let's go to the other end with reduction. Reduction is the gain of electrons. So if we look at our chlorine, what's happening with our chlorine, right? It starts off as a gas, but then we know it's going to form this salt here. Well, that chlorine gains electrons, and once it gains that electrons, right, in this case, it has been reduced to this right here. And we could see it's becoming more negative. So basically think of if you're being reduced, you're becoming more negative or you're gaining those electrons. If you're being oxidized, well, you're losing electrons or you're becoming more positive. You can think of it in those two manners, okay? Another example, we got hydrogen and chlorine forming our acid over here. So electron transfer does not need to be a complete transfer for a reaction to qualify as an oxidation reduction reaction. Okay, so basically you have a little bit of electron transferring occurring, but a full transfer does not have to be a full electron does not have to be transferred. Okay, so we look over here. This is just showing us our electron density map. Basically we got our hydrogens, we got our chlorine, and what we see when we come together, our hydrogen loses this electron density. So if it's losing electrons, it's being oxidized. Chlorine is gaining electrons, so it's being reduced. And this is just kind of showing that with the partial positive on the hydrogen and the partial negative on our chlorine here, right?